All right, hi guys, it's Mr. C back with our level 6 math. Today we're going to do lesson 71 in Saxon. This is on parallelograms, so this is a new thing too. We're doing a lot more with angles and stuff, so we've kind of done some stuff lately with complementary angles, supplementary angles. We're going to extend that now by talking a little bit about parallelograms. All right, so we're going to look at different properties of a parallelogram. This is a parallelogram. We know because it has two sides that are parallel. That's parallel, and then that's parallel. In this parallelogram, A, B, C, D, that's what we call it, A, B, C, D. We don't have to put a line over it or anything. We just put all those letters together. We know that's representing our parallelogram. The measure of angle A is 60 degrees. So what's the measure of C? Well, if we look at it, they look similar, right? And then these ones look similar. Well, that's because they are. In parallelograms, opposite angles are exactly the same. So the opposite angles of a parallelogram have equal measures. That means that angle C, if A is 60 degrees, C is also going to be 60 degrees. Okay? Now, the measure B, these are, let's see, complementary equals 90, supplementary equals 180. So A and B are supplementary angles, okay? Adjacent angles, they share a side and they are supplementary. So that means if we add them together, it's going to equal 180. So if this is 60, we subtract 60 from 180, that gives us 120. That means B is going to be 120. And then because these are opposite angles, this is also going to be 120. So B and D will be 120 degrees. And remember when we write degrees, we just put that little circle thing there. So if it's 60 degrees, we don't have to write out degrees. You can just do that little circle symbol for degrees. All right, now this is cool. We're going to do a model, and I'm going to show you like how you might do this on graph paper. But just imagine like I have something here. They call this a brad and a stiff. Tag board, I don't know what that means. I know I have a tool that I use when I'm doing landscaping that looks like this. It's plastic, and as you move it, it keeps the parallel sides. That's what's going to happen here. So we're going to say 10 inches by 8 inches. So we know the area inside this is going to be 80 inches squared. Now, if we move that down, is this still going to be 80 inches squared in here? We see now it's further across, but it's shorter down. The answer is, well, let's read through this. If we move the sides of the parallelogram back and forth, we see the opposite sides remain parallel. So these are still parallel, and these are still parallel. And they're still equal in length. They're still the same. They're the exact same things we had before. They're just moved. So the angles are the only thing changing here. Though the angles change size, opposite angles remain equal, and adjacent angles remain supplementary. So they're still going to equal the same thing. So with this model, we can observe how the area of a parallelogram changes as angles change. We hold the model up with two hands and slide it, and we see that when it's 90 degrees, it looks like this. And then it reduces to 0 if we push this all the way down. Now, this is what matters. If we want to know the area of a parallelogram, the way we find that is finding two perpendicular measurements. We can multiply the base times the height. So we're not going to multiply, we're not even going to look at the measurement of this side. We're going to look at the base. We're going to look at the height. Now this only works with parallelograms. It doesn't work with other shapes. But base times height. So if we wanted to pull out, you can pull out some graph paper. I'm just going to show you here on the screen how we can do this. If we had a graph paper, we could take this 1, 2, 3, 4, 5 units and just shift it to the side. So if it was 5 by 1, 2, 3, 4, that's going to be 5 times 4 is 20 units, right? But if we shift it to the side, bloop, bloop, to make it a parallelogram, it's still 5 units long, and it's still 4 units high. It's now just shifted over. So is that going to be still 20 units, or is it smaller now, or is it bigger? Well, one way you can do this, if you have graph paper, you can actually move it to the side and then cut it out. And if you do that, you're going to have this part and this part that have the whole squares in it, and you can cut that in half and then just shift it over, which is kind of cool. And if you do that, then you'll line it up and you can count them again. 1, 2, 3, 4, 5. 1, 2, 3, 4. It's exactly the same. It's just shifted over. So we still have 20 square units. even though now it's a parallelogram instead of a square, which is kind of cool. All right, so if we find the area of this parallelogram, again, we don't even need this number. They put it here, but we don't need it. What we need is the height and the base. So if we do height times base, we've got 6 times 5, that's 30 centimeters squared. And again, just ignore that. You don't need it. Okay, so 6 times 5 is 30 centimeters squared, or square centimeters. That's it. So let's just practice going through some parallelogram measurement equations for your homework today. Good luck with it. We'll see you next time. Bye.